Did you know the coldest ocean on Earth might be quietly manufacturing monsters? Today, we need to talk about a discovery that feels illegal to know. The kind of thing that makes scientists lower their voices, even though no one else is in the room. Because beneath Antarctica's frozen seas, something very strange is happening. Something enormous. Something slow, ancient, and wildly overqualified for survival. For decades, we thought cold water made life smaller, slower, less dramatic. But the Antarctic Ocean didn't get the memo. Instead, it did the opposite. It built creatures that look like they were designed by someone who hates proportions, ignores normal biology, and has unlimited patience. And if that sounds dramatic, good. Because this is a place where starfish grow the size of manhole covers, spiders don't fit in your nightmares anymore, and animals solve survival by becoming too big to argue with. Before we dive in, if you enjoy learning about nature's weird side, the part that doesn't make it into textbooks or aquarium gift shops, consider liking, subscribing, or leaving a comment. But only if you actually enjoy this. No pressure. The ocean hates pressure anyway. Now grab some popcorn, or a blanket, or emotional support, because we're about to ask some uncomfortable questions. Why does extreme cold produce giants instead of killing everything? Why do Antarctic creatures break the same biological rules over and over? And why do scientists keep finding animals down there that look unfinished? Imagine this. You're part of a research team. You lower a camera into black Antarctic water. The feed comes back shaky, grainy, and then something moves across the frame. Too slow, too large, too confident. You realize you're not looking at evolution struggling to survive. You're looking at evolution taking its time. Antarctica's ocean looks hostile even on paper. Temperatures hover just above freezing. Sunlight disappears for months. Food arrives late, sparse, and unreliable. By every rule of biology, life here should be minimal, small, and desperate. Instead, you find the opposite. Massive creatures drifting calmly through water that feels like liquid punishment. It's the first sign that something about this ocean doesn't behave the way you expect, and it never has. Let's slow this down. Picture yourself floating here. Your face mask fogs instantly. Every exposed surface aches. The water doesn't just feel cold, it feels deliberate, like it's trying to teach you a lesson. In most oceans, this is where life panics, burns energy, and dies young. But Antarctica runs on a different schedule. Nothing rushes, nothing wastes movement. Survival here isn't about speed, it's about patience bordering on arrogance. For decades, scientists assumed this environment was too extreme to support complex ecosystems. The logic made sense. Cold slows chemistry, darkness limits photosynthesis, scarce food should cap body size. But when researchers finally mapped the seafloor and sent cameras beneath the ice, the footage didn't match the equations. Instead of a barren wasteland, they found crowded communities, slow-motion cities of life, animals so large they seemed misplaced, like props from a different documentary. You start noticing patterns that shouldn't exist. Creatures living far longer than their relatives elsewhere, growth that never quite stops, predators that don't chase because they don't need to. Everything down here behaves as if the usual biological deadlines were quietly canceled. It's unsettling because it suggests that our rules weren't wrong, they were incomplete. Biology didn't fail here. It adapted by doing less, growing more, waiting longer. Antarctica stripped life down to its essentials and discovered something uncomfortable. When energy is scarce and time is abundant, size becomes a solution. So this ocean shouldn't work. It breaks assumptions, it ignores predictions, and yet it thrives. Which is ironic, because the most dangerous thing about Antarctic waters isn't that they're frozen, it's that they're stable enough for monsters to take their time. This phenomenon has a name: Antarctic gigantism. Sea spiders the size of dinner plates, isopods resembling armored lunchboxes, worms thick enough to feel unsettling through gloves. These aren't mutations, they're stable, successful designs. Down here, being huge isn't a disadvantage, it's a strategy. Predators hesitate, prey misjudge, and everything moves slowly enough that size becomes safety. Let's talk about what you're actually seeing. Imagine lifting a rock on the seafloor and expecting something skittish and small to dart away. Instead, a creature the size of your hand just sits there. No panic, no rush. It's not fast, but it doesn't need to be. In Antarctic waters, speed is expensive, energy is currency, and gigantism is a long-term investment. Cold water slows metabolism, which means growth doesn't slam into a deadline. In warmer oceans, animals grow fast, burn hot, and die young. Here, bodies grow like glaciers, millimeter by millimeter, year after year. There's no rush to mature, no pressure to reproduce early, just time, endless, unbothered time. And when growth keeps going, size sneaks up on you. Bigger bodies also change the rules of interaction. Predators have to think twice. Prey can absorb mistakes. A missed grab isn't fatal, it's just awkward. Even wounds heal slowly but steadily. It's not dominance through aggression. It's dominance through inconvenience. Attacking something massive, slow, and well-armored just isn't worth the effort. What really messes with your expectations is how normal this all is down here. These creatures aren't struggling, they're thriving. Antarctic gigantism isn't a glitch. It's a blueprint, refined over millions of years, in an environment that rewards patience and punishes haste. So while the rest of the planet associates extremes with fragility, Antarctica quietly proves the opposite. Sometimes, when nature has nothing but time, it doesn't create monsters. It creates inevitability. Every few years, researchers discover something new and unsettling. A creature too large for its category, too old for its lifespan, too calm for its size. These aren't legends or exaggerations. They're cataloged, measured, and quietly filed away. Because once you accept that Antarctic waters build giants, the only question left is how many we haven't seen yet. Here's how it usually happens. You're on a research vessel, lowering a camera or dredge into water so cold it numbs equipment. The goal is boring. Sediment samples, invertebrate counts, something that fits neatly into a spreadsheet. Then the feed comes back and there's a pause. Not panic, confusion. Because the thing on screen doesn't match the mental template you've been carrying your entire career. It's a squid, technically, but it's far larger than it should be. The arms don't dart or recoil, they drift. Thick, muscular, deliberate, the mantle fills the frame like a moving wall, and the suckers look less like tools and more like industrial hardware. This isn't the kind of animal you expect to stumble upon while doing routine science. This is the kind of animal you expect to hear about later, in a hallway, spoken softly. What makes the moment unsettling isn't aggression. The squid doesn't rush the camera. It doesn't flee. It simply exists in front of it, suspended, watching, as if you're the anomaly, as if you've interrupted something ancient and unbothered. Years ago, scientists assumed giant squid sightings were rare accidents, deep-sea myths brushing the edge of reality. But in Antarctic waters, encounters like this stopped feeling exceptional. Oversized cephalopods, slow-growing bodies, lifespans stretching far beyond expectations. Different species, same pattern. And that's the problem. You're not discovering a monster that evolved recently. You're discovering one that's been down there long enough to stop caring if you notice it. Which means every expedition isn't just research, it's a reminder. The Antarctic Ocean isn't empty. It's just very, very patient. Eventually, the conversation drifts there. Not in press releases, not in documentaries. Usually late at night, on a quiet ship, when the data has been logged and the ocean is doing its endless breathing outside the hull, someone asks the obvious question. Could this thing kill a human? On paper, the answer is almost boring. Most Antarctic giants aren't built for hunting people. They're slow, methodical, optimized for conserving energy, not chasing swimmers who don't belong there in the first place. You are not on the menu. You're barely even a concept. In open water, These animals would likely ignore you the same way you ignore a drifting plastic bag, confusing, temporary, not worth the effort. But that's only half the story. Danger in Antarctica doesn't come from aggression. It comes from scale, from pressure, from the simple physics of being near something that outweighs you by several orders of magnitude. A squid doesn't need to attack to kill you. One curious arm, one accidental coil, one slow adjustment of buoyancy, and suddenly you're dealing with forces your body was never designed to resist. There's also the environment itself, acting as an accomplice. Near-freezing water robs strength in minutes. Visibility collapses. Equipment stiffens. If something large decides to investigate you, not hunt, just investigate, you don't get to negotiate. You don't get to react quickly. You just become fragile in the presence of something that isn't. Historically, there are no confirmed attacks by Antarctic giants on humans, and that's comforting in a technical sense. But it also reflects how rarely humans enter this world at all. Absence of evidence isn't proof of safety, it's proof of distance. Because the real danger isn't teeth or tentacles. It's the realization that these creatures don't need to be violent to be lethal. They just need to exist. And in an ocean that rewards patience, that's more than enough. This isn't a finished story. Antarctic waters are still cold, still oxygen-rich, still slow. The factory never shut down, which means evolution is still running its longest experiments here unsupervised. Somewhere below the ice, something is growing at a pace humans don't notice. Not fast enough to panic, not slow enough to stop. That's the unsettling part. Nothing about this system is past tense. The same conditions that created giant squid, oversized predators, and ancient lineages are still perfectly intact. The conveyor belt is still moving. Growth still happens in years measured by decades. Mistakes still get ironed out over centuries instead of generations. You won't see sudden changes, no dramatic spikes, just incremental mass, added quietly, patiently, while surface life argues about climate graphs and timelines. Down here, evolution isn't reacting, it's continuing. And that means every expedition is only a snapshot. A single frame pulled from a process that doesn't care about witnesses. Because Antarctica isn't done. It's just taking its time. And that's usually when nature builds its most impressive things.